In this lesson, we are going to talk about how to prove the lines are parallel. So, in the first part, we learned about the names. And so in this lesson, we are going to talk about how we can use the converse to prove lines are parallel if we know the angles. One quick thing, the parallel postulate here is listed. There's always only one line that is parallel through any point that is not on the other line. And then perpendicular transversal converse, if two lines are perpendicular to the same line, then those lines are parallel. So that is one other way that we can prove them parallel, but this is our one that we're going to be using for the most part. So before we knew they were parallel, and then we had a relationship such as corresponding, alternate interior, alternate exterior, and same side or consecutive. And then for this lesson, we now are going to be given the angles, and then we're going to prove those lines are parallel by the converse of whatever that relationship is. So alternate interior, but we're going to use the word converse because we're going the other direction. Remember when we wrote our converse statements, we kind of switched the hypothesis and conclusion. So I'm going to have you kind of repeat that a couple of different times, at least in class. What proves parallel? Converse. What proves parallel? Converse. What proves parallel? Converse. And so we're going to use the converse of these relationships that we've already learned. So for example, 1 and 6 are congruent. And we know that it would prove line L and N, because those are the ones that it's touching, parallel by the converse of, and then we name what kind of angles they are. Alternate exterior angles. And that's it. So let's take a look next at 2 and 3. So the lines that would be parallel would be L and M by the converse of alternate interior angles, and you can add the word angles. All right, next we have 4 and 5. Let me get rid of all my markings here. So 4 and 5 are supplementary, and so M and N are parallel because they're same side, but again, we need the word converse, either at the beginning or end. Converse of same side or consecutive interior. And then we have 3 and 5. So let's mark that one. Nope. Three and 5. I'm going to get rid of my green markings first, though. There we go. So 3 goes alongside M, and 5 goes alongside M, so M and N would be parallel, and those are corresponding, so converse of corresponding angles would prove that those lines are parallel. So down here it says, find the measure of angle MRQ, and that's this one right here that says 5x plus 7, so that the lines are parallel. So that would mean that we would need alternate interior to be congruent. So these would need to be congruent in order for those lines to be parallel. So we're going to go ahead and set them equal. And kind of doing that converse of alternate interior, and then solve. Subtract 5x. And divide by 2. X is 14. All right, so lastly, we're going to kind of look at a couple of proofs. Like I said, they won't quite go fully away for a little while, but just a few here and there. So remember, what always goes first? Given. And then we have corresponding angles. They're giving us those. Vertical angles, they're giving us those. And then they're putting this one and this one together, the first and the last. So remember, when they put the first and the last, when they're congruent to the same angle, that is the transitive property of congruence in this case. And then, moving my picture there. Go ahead and try this next proof on your own. At least you know what should go first. And then it's telling you corresponding angles are congruent. So I'll tell you, you're going to do corresponding to angle 1. What corresponds to angle 1? And then vertical, what is vertical to angle 5? Give you that little hint there. Go ahead and check your answers that you have given here, and that you have angle 5 is corresponding to angle 1. So those are congruent. And then 5 is going to be vertical to 8. So now we can go ahead and put 1 and 8 together, again, just like on that first proof with the transitive property of congruence. So if you want to try this last one, go ahead and give it a go. This just means the linear pair postulate, LPP, linear pair postulate, since we're using the word linear pair there. But given, and then what is congruent? So if we have equals here, we probably had a congruent up here, since it's talking about the corresponding angles are congruent. And so it would be angle 1 and angle 5. And then if it's congruent, then it's equal is definition of congruent angles, or just definition of congruence. And then we are replacing, if you'll look at from this step 2 to this step 3 or 5, the only difference is we're replacing the measure of angle 1 with a 5. So substitution.